University of Sheffield SmartProducts demonstration. This video demonstrates the integration of a set of tools for the SmartProducts developer and interaction with workflows generated to guide the carrying out of different activities. This video highlights intercommunication between independent tools via an integrated framework consisting of a workflow information extraction tool, which generates workflows from procedures or instruction sets, a workflow editor for visual creation and editing of workflows, and a data browser with a Semantic Clipboard for data exchange between tools and repositories. The workflow information extractor automatically processes descriptions of workflows from, for instance, procedures or instruction sets, such as recipes, identifies structural elements and domain-specific concepts in the data by learning from sample instances of concepts stored in a seed file, and it represents the output in XPDL format, which is the XML process definition language. The workflow information extractor takes as input the path to input documents, the path to domain ontology files, and the path to the seed file. The input in this case is a batch of recipes downloaded to the user's file system from the internet. Preset defaults for the input and output fields will be used if none are specified. The information extraction process runs in a background thread. This allows the user to carry out other tasks while information extraction takes place. The input and output form is disabled while the information extraction process is running to prevent multiple processes running concurrently. A log is printed out to inform the user of the current status of the process. The workflow information extraction process consists of two stages. Workflow extraction identifies structural elements of workflows. Workflow annotation annotates workflows according to domain ontologies and seed data. While we're waiting for the information extraction process to complete, let's look at the support for browsing and exchanging data within the user interface. The integrated framework includes independent tools as plugins. Intercommunication between tools is achieved through data exchange. The user interface regards each piece of information as a visual data object. For each data object accessed within the framework, a reference is created. This reference points to the actual information, such as a local file or a remote location, and this is stored in a reloadable session. Each tool interprets data content and updates based on tasks carried out using the data. The data browser displays each data object as a thumbnail with a descriptive icon, for example a text file or image file. It also displays basic metadata such as the file name or label and location, as well as user-specified tags describing content. Data objects may be moved between tools using drag and drop methods. The Semantic Clipboard is a temporary visual store for recently used items. While waiting for the information extraction process to complete, the developer starts to browse other XPDL files. These may be on the local system or in remote repositories mapped to the user interface. The developer selects one item of interest and drags the thumbnail to the clipboard. This creates a new bookmark. The developer goes back to check on the information extraction process. This is just completed. The two information extraction subprocessors generate temporary files before writing the final output as XPDL to the selected output directory. The developer refreshes the data browser window to display the automatically extracted workflows. The developer then selects two more workflows, vegetable stir-fry and omelette, and then drags the thumbnails to the clipboard to create new bookmarks. We switch now to the workflow editor, which may be used to create new workflows or to edit automatically created workflows. We illustrate the latter. The developer starts the workflow editor and drags the bookmark for the omelette into the window. The workflow editor interprets this as an open workflow task, loads the workflow in the window, and displays the graph view. In order to browse the domain ontologies in use, the developer switches to the ontology view and selects the Phillips ontology. This is used to annotate the recipes in the input folder. Three classes are displayed: cooking task type, kitchen utensil, and ingredient. The developer selects the concept ingredient and browses the instances generated during the information extraction process. To create additional roles, the developer switches back to the graph view and creates a second participant role. Hovering over an activity block brings up a tooltip with extra information. Selected tasks in the workflow are then reassigned to the new participant by dragging the activity blocks into the second swim lane. The developer wishes to add an annotation. Double-clicking on an activity block brings up the Properties window. The developer selects the SmartProducts Annotation tab and clicks on the New Annotation button to add new metadata to the activity, in this case to mark ingredients. The user may scroll through the list containing the ontology concept instances sorted alphabetically in order to browse the options available, or they may type in the field to jump to a known item. To store the selection, the developer clicks on the Add Tag button on the bottom left of the window. Each annotated activity block in the graph window is highlighted using color coding in orange. Reloading sessions saves the user's session to a local file when the developer closes the application. This allows the developer to retrieve previously accessed data and annotations at a later point in time. Other system settings may also be saved, such as information extraction defaults. The developer restarts the system and retrieves a previously saved workflow. Double-clicking on a selected thumbnail in the data browser opens the file using the default program for that file type. For the XPDL file, this is the workflow editor. Browsing history is done in the Context Config tab in the Properties window. These attributes are used to allow activities to be triggered by context events such as sensor readings. The developer saves the changes made in this session as a new workflow. A reference to this is stored in the user's session. Switching to the UI data browser shows that new data objects have been added to the developer's information workspace. Refreshing the window shows the reference as a new thumbnail at the bottom of the list. The user drags the thumbnail into the clipboard and edits its label to provide a more useful description, which is displayed as a tooltip on mouse over.